This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. The topic is Material Addition Processes Part 4. Okay, so this is the content beyond the syllabus under Unconventional Machining Process. Okay, so at the end of this session, student will be able to understand the rapid prototyping fundamentals. Okay, right. First of all, let us discuss the classification of RP techniques. Okay, right. During 1991, Kruth classified the RP techniques according to the raw material used into liquid based techniques, powder based techniques, solid based techniques. Okay, some of these methods depend on solidifying a liquid polymer by the impact of light or laser, or by the curing of powders to create the prototype. Okay, so other processes are based on melting, deposition and resolidification of plastic or resin materials. Okay, so basically it has classified into rapid prototyping is classified into liquid based techniques, powder based techniques, solid based techniques. Okay, so basically it depends on solidification, okay, and curing of powders to create the prototype. Okay, and other processes are based on melting, deposition and resolidification of plastic or resin materials. Okay, right. Now let us discuss liquid based techniques. Okay, liquid based techniques. So the following are the liquid based techniques: stereolithography, okay, holographic interference solidification, beam interference solidification, solid ground curing, liquid thermal polymerization, fused deposition modeling, multi-jet modeling, ballistic particles manufacturing, shape deposition manufacturing. Okay, these 9 are comes under liquid based techniques. Okay, right. Powder based techniques. Okay, second one, powder based techniques. First one is selective laser sintering, laser engineered net shaping. Okay, so selective laser sintering, SLS. Okay, laser engineered net shaping, LENS. Okay, third one, three-dimensional printing. Okay, right. Now let us discuss the first one, selective laser sintering under powder based techniques. Okay, so under powder based techniques, now we are discussing laser sintering, selective laser sintering. Okay, right. In short, it is SLS. Okay, selective laser sintering is a free-form fabrication method based on sintering of the metallic or non-metallic powders selectively into an individual object. Okay, selective laser sintering is a free-form fabrication method based on sintering of the metallic or non-metallic powders selectively into an individual object. Okay, right. Now as shown in figure 1. Okay, selective laser sintering setup. Okay, a thin layer of fusible powder is laid down and heated to just below its melting point by infrared heating panels at the side of the chamber. Okay, right. Now look at this. Okay, so this is laser. Okay, scanning mirror, and this is roller. This is object. Okay, so here powder delivery and sintering. Okay, so from this piston cylinder arrangement, the powder will be supplied. Okay, and a roller rolls over the powder delivery system so that it will add a layer on the previous layer of the object in this sintering. Okay, so this powder delivery will be constantly uh, added. Okay, and roller will rolls that amount onto this one. This one will get down. Okay, so here this will go up, this will go down. Okay, right. Here the scanning system, as per the required profile, the scanning system will deflect. Okay, right. Right. A laser beam guided on the basis of a three-dimensional CAD system of the part to be produced. Okay, sinters and fuses the desired pattern of the first layer of the object in the powder. That's what we have discussed. Okay, so one side powder will be supplied. Okay, and that amount of powder will be rolling by the roller arrangement. Okay, so that it will be supplied to the previous previous layer of the object to be made. Okay, and that it will be fused with the laser setup. Okay, so then a laser beam guided on the basis of a three-dimensional CAD system of the part to be produced. Okay, so what is the input to this CAD model? Computer aided design model. Okay, and later it sinters and fuses the desired pattern of the first layer of the object in the powder. Okay, so here that it will be fused. Okay, because of the laser setup. Okay, right. So here the laser will fuse as per the CAD model, computer aided design model. Okay, so a 3D model, 3D CAD model will be the input. Okay, so the laser system, okay, will follow this 3D CAD model. Okay, right. Next, this first fused layer descends the roller, spreads out another layer of powder, and the process repeats. Okay, SLS relies on the supporting strength of the powder around the partially fused object. Okay, so selective laser sintering relies on the supporting strength of the powder around the partially fused object. Okay, right. Therefore, support columns for any overhanging parts of the component are not needed. Okay, so here overhanging parts do not require any support. Already we have discussed that. Let us say for this kind of thing, okay, so it can be rest on the ground. Okay, so at this stage it is a overhanging type. Okay, so because of the self weight, it should come down. Okay, in fact we need to have some support, but here support columns for any overhanging parts of the components are not needed here. Okay, right. A variety of materials can be used, including polymers, epoxy, wax, metals, and ceramic with the appropriate binder. Okay, so after the object is fully formed, the piston is raised to elevate it. Okay, so here one side the delivery system will supply the powder constantly, and the object to be made in that piston cylinder arrangement is gradually getting downwards. Okay, right. Excess powder is simply brushed away and a final manual finishing may be carried out. Okay, so usually we supply the sufficient powder. Okay, and of course some excess powder we have to supply as per the requirement. That low excess powder will have to be simply brushed away and a final manual finishing may be carried out. Okay, right. Next, although surface finishes and accuracy are not quite as good as with stereolithography, the material properties can be quite close to those of the intrinsic ones. Okay, so here surface finish and accuracy are not quite as good as with the stereolithography. Okay, the material properties can be quite close to those of the intrinsic ones. Okay, the method has also been extended to provide direct fabrication of metal and ceramic objects and tools. Okay, right. Advantages of selective laser sintering, SLS. Okay, it produces the toughest components compared to other RP techniques. Okay, so this technique produces the toughest components compared to other RP techniques. Okay, next, a wide range of materials can be used, including metal, plastic, ceramics, wax, nylon, elastomers, and polycarbonate. Okay, what are the wide range of materials that we are using in selective laser sintering? Metal, plastic, ceramics, wax, nylon, elastomers, and polycarbonate. Okay, right. A relatively short production time, approximately 1 inch in hour, is possible. Okay, approximately 1 inch per hour. Okay, right. No post curing processes are needed. Okay, so here post curing processes are not required. Next, no additional support is required during the building process. Already we have discussed. Leftover powder can be reused. Okay, so while we are supplying the powder, okay, when the rolls adjust this powder for the requirement, exact requirement, that will keep on the previous layer, and the rest of the powder will come out, that it can be collected separately and that it can be reused. Okay, again that it will be again supplied constantly. Okay, right. Different parts can be quite right on the top of others. Okay, different parts can be built right on top of others. Okay, so here one part will be built. Again, another part will be built on the top of others. Okay, right. Next, disadvantages of selective laser sintering. Okay, a rough surface finish is produced due to the stair-step effect. Okay, because of this stair-step effect, a rough surface finish is produced. That is the one of the disadvantages of the selective laser sintering. Okay, right. The time needed to heat up the powder and cool down the model after it has been completed is approximately 8 to 10 hours. Okay, so here the time taken for the heating up and cooling down will be much, so that it will take approximately 8 to 10 hours. Okay, the time needed to heat up the powder and cool down the model after it has been completed is approximately 8 to 10 hours. Okay, so before we go to the next point, let us come to know whatever it may be the process, there will be some negatives or some disadvantages. Okay, of course, when compared to advantages, these disadvantages are neglected. Okay, right. Toxic gases are produced especially when plastic materials are used. Okay, see here, that is not the problem with this process. Obviously, when we fuse plastics, that will produce toxic gases. Okay, this cannot be a biggest disadvantage, but of course, we have to fuse with this method, with this laser sintering. The plastic will produce toxic gases. Okay, right. Components are less detailed than those produced by stereolithography due to a high processing temperature and high shrinkage. Okay, components are less detailed than those produced by stereolithography due to a high processing temperature and high shrinkage. Okay, so here high processing temperature and high shrinkage. These two are the two important parameters. Next, powder based techniques. Okay, selective laser sintering. So far we have completed. Now laser engineered nut shaping. Okay, now come to laser engineered nut shaping. Okay, look at this figure. Okay, figure 2. LENS, laser engineered nut shaping. LENS. Okay, here a high power laser is used to melt metal powder supplied coaxially to the focus of the laser beam through a deposition head. Okay, so look at this system. So here the laser will be supplied. Okay, stream of layer from the CAD model input. Okay, so based on the CAD model profile, the laser will be supplied and subsequently the mirror deflects accordingly. Okay, here the laser will be supplied, but as per the CAD model, the mirror deflects as per the path or profile required to fuse the material. Okay, right. So here powder metal supply. Okay, so parallelly the powder metal supply be there and the mirror deflects, and from this focused beam the molten material will be supplied as per the path. Okay, so parallelly the powder material supply and the beam, laser beam, will be directed into the material. Okay, so that the fused material will be over the previous layer of the prototype and it will be solidified. Okay, so this one is shroud gas inlet. Okay, this is XY table. Okay, so here the table will move as per the profile. Okay, just like our printing machine. Okay, so based on the requirement of the profile and path, the table will move in XY directions, so that uh, the material, fused material, will be occupied that profile, and subsequently it will be solidified in order to get the final shape of the required prototype, but it will happen layer by layer. Okay, right. Now let us discuss the what we have seen in that figure. The XY table is moved in raster fashion to fabricate each layer of the object. Okay, already we have discussed. Suppose if it is like this, what will happen? First this one, next this one, again this one, again this one, this one, this one. So this layer will be, so here gap, again here the entire thing. Like that it will make layer by layer. Okay, right. Typically the head is moved up vertically as each layer is completed. Okay, so after completion of each layer only, again the next layer will be happen. Okay, it is, let us say this is in 3 dimension, then layer by layer it will be added. Okay, suppose if you take a shape like this. Okay, in the first instant this would be, again second instant, again third instant. See here the profile is not uniform, so different cross sections. Okay, so it will occupy layer by layer. Okay, so the laser beam is delivered to the work by a simple right angle mirror. Okay, that's what we have seen here. Okay, so it deflects the supplied laser beam into the powder metal supply zone. Okay, so here the focused beam will be directed towards the table, so the table will move in XY directions. Okay, right, just 1 minute. Metal powders are delivered and distributed around the circumference of the head, either by gravity or by using an inert pressurized carrier gas, which can also be used to shield the melt pool from atmospheric oxygen. Okay, right. It also provides a better control of properties and promotes layer to layer addition through better surface wetting. Okay, right. A variety of materials can be used as stainless steel, Inconel, copper and aluminum. Okay, of particular interest are reactive materials such as titanium. Okay, most systems use order materials, but there has also been work done with material provided as fine wires. Okay, so in this case the material is fed off axis to the laser beam. Okay, right. The building area is usually contained with a chamber, both to isolate the process from the ambient surroundings and to shield the operators from the possible exposure to fine powders and the laser beam. Okay, the laser powder used varies greatly from a few hundred watts to 20 kilowatts or more, depending on the particular material, feed rate and other parameters. Okay, so with this laser engineered net shaping has fewer material limitations than SLS. Okay, doesn't require secondary firing operations as some of the processes do, and can also be able to use to repair parts as well as fabricate them. Okay, so initial applications are concentrated on the fabrication and repair of injection molding tools and the fabrication of large titanium and other exotic metal parts for aerospace applications. Okay, right. So with this, let me conclude. Okay, so this is three-dimensional printing. Okay, which offers the advantages of speedy fabrication and low material cost. Okay, in fact, it's probably the fastest of all RP methods. Okay, look at this process. Okay, powder delivery and fabrication. So here, liquid adhesive supply. Okay, so this is inkjet head. So this is powder bed. Okay, right. Recently, color output has also become available. Okay, however, there are limitations on resolution, surface finish, part fragility, and available materials. Okay, right. The closest competitor to this process is probably fused deposition model. Okay, FDM. Right. So these are the references associated to this. So with this, let us conclude. Okay. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.